In this IG Apps tutorial, we'll create an image classification app that can distinguish between several objects, in my case a banana, orange, pen, and sticky notes. We'll create our machine learning model using Google's Teachable Machine, then deploy the TensorFlow Lite model in our Android app. Let's get started. We'll head on over to teachablemachine.withgoogle.com, which is a web tool that allows us to create machine learning models that are fast and accurate. We can click on Get Started. And for the project type, we're going to create a new image project. That way we can create an image classification app. And I'll click on Standard Image Model. And now you can see that we can upload images for our different classes. In my case, I'm going to be using bananas and other common objects. You're welcome to use whatever you want. We have the option to add image samples using a webcam or uploading them. I'm going to go ahead with the webcam and click on that option. Now you can see that there's a live feed of my webcam. And I'm going to hold on this button to record images of my banana, and I'm going to do so from various different distances as well as angles. And once I've gotten a sufficient number of banana samples, I'm going to move on to my second class, which for me is going to be oranges. Once again, you can use whatever you want. I'm going to have a total of 4 classes, and I'm going to speed through the process of getting images for those classes. Now that I have a sufficient number of image samples for my 4 classes, I can click on the Train Model button to train the model on these images that we collected for our 4 classes. And this can take a couple of seconds, so you can pause the video and wait for your model to finish training before continuing. When our model has finished training, we can see a preview over here in real time. So you can see that I have a sticky note displaying, and it knows that this is a sticky note. I'm going to switch this over to my banana, and you can see with about 100% confidence it believes that this is a banana. I'll test it one more time with an orange, and you can see in real time it knows that that's an orange. And if I pan over to my sticky note, it knows that's a sticky note. If I focus in more on the banana, it knows that's a banana. So now we know that our model is trained and it's working with pretty great accuracy and confidence. We're ready to export our model. That way we can use it in our Android app. So we'll go ahead and click on this export model button over here. And you can see there's different formats. We're interested in TensorFlow Lite for our Android application. You can keep it on floating point and just press on the download my model button. And this can take a couple of minutes, so once again you may want to pause the video and continue it when your model has finished downloading. So my model has finished downloading and I have this zip file over here. I'm ready to head on over to Android Studio and use this model that we downloaded in our Android app. So I'll switch over to Android Studio. And to add our TensorFlow Lite model in our Android app, we're going to go over to our app folder on the left. I'm going to right click on it, hover over New, and scroll down and select Other. In Other, we have this option to add a TensorFlow Lite model. That's what I'm going to select. Now I have to specify the model's location, so I'll click on this little file icon over here, and my model is in my downloads folder. I'm going to unzip this, and inside over here you can see that we have labels.txt and model unquant.tflite, which is our model that we downloaded that's already been trained. I'm going to rename this to model.tflite, and I'll just drag and drop this over here and click open. Okay, now I'm ready to press finish. So it's syncing the project, and over here for our model.tflite, it shows us some sample code for actually using our models for inferencing. So in Java, which is what I'll be using for my Android app, this is how we'd create an instance of our model, feed it some input, and get an output. So we'll be using this code in some time. I quickly want to show you the layout that I have for the Android app that I demoed earlier in this tutorial. I'm not going to be going through the process of actually coding the layout because that would take too much time. Instead, I'll slowly scroll through what I already have over here, and you can take some time to copy this down. I also have a link to the GitHub repository in this video description, so if you don't want to type this all out, you can visit that link and copy and paste the code that I put up there on GitHub. Essentially, our app will contain an image view displaying the image that the user took after pressing the Take Picture button. We'll also display a text view with the model's classification with the highest confidence, so for example, banana or orange. And we'll display the confidences for all 4 classes as percentages in this text view over here. In Android manifest.xml, we want to specify that we need to use the camera. So we'll say uses permission, Android name, android.permission.camera. Here. Now in my main activity.java, I already have some code, and I provided a link to this code. That way you don't have to type it out. It's in my video description. I provided it as a GitHub gist. That way you can save some time instead of typing this all out. The main thing that we want to do is get the image from this intent called data, and then using this image do the actual inference with our model. So that's the main focus of this tutorial, and that's why I've provided the link to this code. So over here in our if statement, we're going to get a bitmap called image using this intent after the user has launched the camera. So we'll say a bitmap, and then we'll say data.getExtras, which gives us a bundle, and we want to get specifically data. So now we have this bitmap called image that contains the image that the user took from their camera. What I'm going to do is I'm going to crop it. I'm going to center crop it because we want to feed a square image into our neural network, our TensorFlow Lite model. So that's what I'll say int dimension equals math.min image.getWidth and image.getHeight. So this will give me the smaller of the two of width and height. And now I'll say my bitmap is going to be equal to, I'll use this thumbnail utils function called extract thumbnail, provide my image, my dimension, and my dimension. So this will perform as center crop for us. And now we can set our image view to this image by saying image view.set image bitmap image. The last thing that we're going to do regarding altering this image bitmap is we're going to have to resize it to 224 by 224 because that's what our model takes in as input. If you head on over to model.tflite, you can see over here the image size it receives is 224 by 224, and then the 3 is for RGB channels. So I'm going to create a field for my image size, that way I don't have to retype it everywhere. I'll set it equal to 224, and I'll say image equals bitmap.createBitmap image, and I'll pass in my image size for the width and height. Oh, this should be create scaled bitmap. Yep, and now we're ready to actually do our classification using our model. So I'll create a function called classify image, and I'll pass in this image bitmap. So above my onActivity result, I'm going to create a void function called classify image. Its first and only parameter is going to be our bitmap image that we're passing it after the user takes a picture from the camera. And this is the part where we can head on over to our model.tflite file where we're provided with some sample code for using our model for doing predictions. And we can copy and paste this into our classify image function. So what this line of code over here does is it creates our model, and this should be get application context. Over here we're creating our inputs for the model. This is where we actually make our model process that input, and we get the output over here as a tensor buffer. So you can see that one thing is in red, and that's the byte buffer over here. That's because we're going to have to take this bitmap image that we got, this data for our model, that's the input, and make it into a byte buffer that we can then pass into our model. So in order to do this is going to require a couple of steps. The first thing that I'm going to do is I'm going to create a byte buffer called byte buffer, and this will be equal to byte buffer dot allocate direct, and I'm going to need 4 bytes for my float, and then I'm going to need some more bytes for the image. So remember, image size is 224, and then I'm going to need there's going to be a fourth dimension, which is the number of channels R, G, and B. So that's why times 3. So this is how much space we need to allocate to our byte buffer for each image. And now I'll say byte buffer dot order byte order dot native order. And one more thing that we have to do is actually get the pixel values from this bitmap image. So I'm going to create an array of ints to store those pixel values, and because our image size is image size times image size, that's going to be the size of this int values array. To actually get the pixel values, I am going to say image.getPixels, pass in my int values, 0 image.getWidth, 0 and 0 for the x and y, image.getWidth, image.getHeight. And now int values, this array over here, will contain the pixel values from our image. The last thing that we need to do is actually iterate through this array of values and add those pixel values to our byte buffer. So I'm going to have a variable called pixel to keep track of which pixel we're on. I'm going to say for int I equals 0, I is less than image size, I++. For int j equals 0, j is less than image size, j++. So this is in order to go through all 224 by 224 pixels in our image, which are now stored in int values. I'm going to say int val equals int values of pixel plus plus. So this will give us the value of the pixel, which, if you remember, is going to be R, G, and B all rolled into one. This is why I've copied these 3 lines of code over here, which are going to perform bitwise operations in order to extract the R, G, and B values from our pixel. So now our byte buffer contains the R, G, and B values for all the pixels in our image. So now we're done with the steps for creating the tensor buffer variable that will contain our image as input to the model. And we've also have the code for running the model inference and getting the result called output feature 0. Using this output feature 0, we can get a float array of the confidences for each of our classes. So the way that I'm going to do that is by saying float confidences equals output feature 0.getFloatArray. And this will, in my case, give me an array containing 4 elements. Now we want our app to display the classification that has the greatest confidence. For example, if we have an image of a banana and the model thinks that's a banana with 98% confidence, we want to display banana in our app. In order to do this, we're going to have to iterate through our confidences array and find the position with the highest value. So this is just going to require some basic code and logic to find the maximum in our array. So what this code does is it goes over the confidences for each of the 4 classes, checks if that confidence is greater than the biggest one we found so far, and then it updates the biggest one we found so far, as well as the position of the class with the greatest confidence. So now max pos is going to be the position in this confidences array with the greatest confidence. And now we're going to create a string array of our classes. So the order that I took the pictures in on Google's Teachable Machine were banana first, then orange, followed by pen, and then sticky notes. And the idea is that I can use this array to easily set my text view called result. So result.setText, and this is going to be the class with the greatest confidence. And remember, we found the position with the greatest confidence. It's called max pos. So that's why over here I'm going to say set text classes of max position. And the second thing that I'm going to do is I want to display the confidences for all 4 classes. So that's what I'm going to say string s equals, it's going to be empty initially. And now what this bit of code over here is going to do is it's going to iterate through every single one of our classes, display that class name followed by a semicolon, and then it's going to display the confidence for that particular class rounded to 1 decimal place, and then followed by a decimal sign. Then it's going to add a new line character for the following classes to come on the lines below. Now we can go ahead and say confidence, which is our confidence text view, that's set text, and then pass in s. And we're ready to run our app and see the results that we get. So now I'm running the app on my device, and I'm going to click on the take picture button. Here I have an orange sitting on my desk. I'm going to take a picture of it, click OK, and you can see that's classified as an orange, and our confidences text view displays banana with 0.1% confidence and orange with the most at 99.9%. I'm going to click take picture again and test this on a banana this time. I'll actually go close to the banana and see whether the app is still able to recognize what it is. And yes, it's able to do so with 99.6% confidence. I'll test it really quick on the sticky notes. I'll skip the pen. And here it's detected, I classified that as being a sticky note with 100% confidence. So in this IJ Apps tutorial, you'll learn two main things: how to use Teachable Machine to train a machine learning model with high accuracy and speed, and then how to use a trained TensorFlow Lite model in your own Android app. In the upcoming tutorials, we'll code our own machine learning model using Python and TensorFlow, and then deploy our custom machine learning model in our own Android app. If you found this tutorial useful, please make sure to give it a like and share it with friends. And if you have any questions or tutorial requests, make sure to drop them in the comments. See you in the next tutorial.